So I know that we want to find an efficient way to calculate combinations, but uh, let me show you something that's slightly different. It's another way to calculate permutations. But let me put it this way. So how do we permute? So to permute, uh, let's say n objects in n places, in in r places, we can do the following. First, pick r elements from the set containing n, and to present our objects. Now, we can do this in any order, so the multiplication principle applies. Now, there, there's some things that we need to say. First, uh, the first task can be counted in the following ways. You have to pick r from n. Well, that's exactly what we just described. It says that the first task can be performed in c n r ways. That's just the definition of combinations. The second, well, I need to present our objects. So imagine yourself saying, okay, I have this item and this item. Well, I can present it in this way and in this way, or in this way and in that way. Well, that amounts to permuting the objects. So to perform the second task, I can do it in the following way. So I have R objects, and I need to permute all of them. So now, look, I already know how to permute. So by the multiplication principle, we have that the permutations of n objects in r places is the same as the number of combinations of n objects of r objects out of n times the number of permutations of r elements. So, well, look, we already know how to compute this. We already know how to compute this. So we get the following conclusion. So C n r is equal to P n r over P r r. Now, this one that we have here, we already know a formula. It is n factorial over n minus r factorial. For this one, oh, we already know a formula. This is r factorial over r minus r factorial. Just from this formula. So, reducing this, well, this is 0, and 0 factorial is 1 by definition. So I have n factorial over n minus r factorial times r factorial. And there we go. We obtain a formula for combinations through a formula from permutations. Now, let me just give a brief example. To compute C for 2, that amounts to do the following: 4 factorial over 2 factorial times 2 factorial. Well, what is this? This is 4 times 2 times 3 times 1 over 2 times 1 times 2 times 1. Well, let me reduce. Let me just modify this. I know this is true, but let me just modify this way. So I cancel this against that, and this results into this 2 times 3, which is 6. So now just verifying with the pizza problem.